Hello everybody and welcome to a new tutorial about Freecad CfdOF. This is the 8th tutorial in English. In this tutorial I will show you a simulation of two-phases flow. For this simulation we need two mediums. The first medium is water, the second medium is air. In this simulation the gravity will be regarded. In order to save time, this will be a two-dimensional simulation. I will also show you how to build up a simulation with two dimensions, and I will show you what effect this model has. This simulation will be a transient simulation. This will be our first transient simulation. All other simulations we've performed before were steady state. We start with Freecad. We insert a new file, and we're going to the part design workbench. We make a new body, make a sketch. We will sketch in the XY plane and click OK. We build up a polyline. We go straight up, then go a bit to the left, then we go right, we go down, we press 3 times M, so we construct a radius, touch this line, go here, and touch 3 times M, and go to this point. So we have too much constraints, and we will remove constraint number 9. So that looks okay. First we must say that this point is on the y-axis. So next thing we will do is to define this angle. This angle is 110 degrees. Then we define this angle. This angle is 75 degrees. We define the radius. This radius will be 50 millimeters. This radius is 5 millimeters. And here we have we'll have a tangent transition. Here also. No, that doesn't seem to be necessary. Okay. Then we can define the height. The height is 0.1 meter. We define this distance. This distance will be 50 millimeter. The distance of this point is 80 millimeters. And we define this distance to 40 millimeters. So now our model is complete, and we can close, and we can pad this up to 30 millimeters. So let's take a look. Looks quite okay. And now what we need is a second body. We go to the model and insert a new body. For this body, we need also a new sketch. We will define this sketch in the XY plane. Okay, what we see is that we have the old body here, and this is a bit disturbing. So we go again to the model, go to the first body, and go to the representation. We will increase the transparency. We say 80%. And we go back to the sketch. Now it should work better. We create a polyline. And we draw something like a rectangle. So in this case, it's not possible to use this line because we have two different kind of bodies. But of course, we want to have the same angle that we have here. So we know that angle. So we can define this angle. So this angle will be 15 degrees. And we say that these both lines are parallel. And we say that these both lines are parallel. And we define an angle of 90 degrees. Looks good. And now we can move it so this body should be a bit outside and should be in this area. This looks good. So here we can define a length. We take this definition and say 83 millimeters, that's good. And we define the height. 43 millimeters. It's also okay. We define a distance from the x-axis, 0.1 meter, that's okay. And we define a distance from the y-axis. We say 46 millimeters, that's okay. We can close and pad this also up to 30 millimeters. So now our model is complete, and now we can change to the CFD workbench. We can insert an analysis container. We go to the physics model, As I said, we want to have a multi-phase simulation. So you see that multi-phase is only available if you click on transient. So now it's enabled. We can click on multi-phase. We want to consider viscosity, and the model will be laminar. That's okay. You see also that we have here gravity. It's important to check the axis. In this case, it's running into negative y direction. You see here that um, our model is built accordingly. So this is working. This is good. So we can close. Now we can go to the fluid properties and make a double click on it. And the first property will be water. That's okay. And now we can go to the CFD analysis and insert the second fluid property. In this case, it is air. And now you see that we have 2 times a fluid property. In order to distinguish these properties, we will rename these properties to fluid property air. And we will rename this fluid property to water. Now we can go to initialize field. And you see here that, so this is, as we've seen before, the velocity will be a potential flow. That's okay. For the pressure, we must define a value. It's not possible to, in this case, it's not possible to define this via potential flow. And we define the volume fraction. So here we say that the property that the fluid is water. And for the whole model, the volume fraction will be 0. So this is okay. And now we must define an initialized zone. So for the zone, you need a solid. We click on this second solid, add this. And for this solid, we will define the volume fraction to 1. So now it's complete. So this looks good. So now we can go to the mesh. I will show you how to create a mesh. I will, in the first approach, I will show you how not to do this. I click on the element dimension. This is 2-dimensional, and the measure will be Gmesh, and the base element size will be 2.5 millimeter. If I now click on write mesh case, I'll get an error. So here you see the runtime error for 2D meshing. 2 separate parallel 2D bounding planes must be present as the boundary conditions, and so on. So I've made this intentionally wrong. So what we must define are 2 boundary conditions. We close. We click on this plate and go to the boundary conditions. We say that this is a constraint, and the subtype will be 2D bounding plate. Okay, we click on OK, and we will rename this constraint. So the label is not constraint, but we say front plate. So we rotate the model and click on the backside. And we click also on the constraint, two-dimensional, and we rename this to backside. And here we can say front side, that's better. So now we have the definition for the front side and the back side. So that's okay. We can now go to the mesh again and try a second time if it works now. So we get the message that the mesh case is written, and we can run the mesher. So after nearly 40 seconds, meshing is complete. We can review the mesh. So meshing was a 2D meshing, and when you look on the front side, it looks like a two-dimensional meshing, but in this direction, in the this is the Z plane. So in the Z direction, we see that we have elements. So in a way, it is a bit like a three-dimensional, but only with one element. But internally, it's calculated two-dimensional, and so the volume flow is only calculated in x and y direction, not in z direction. So this is um, how CFD computes a two-dimensional simulation. Our mesh is complete. We can close, and now we can go to the CFD solver. In this case, I did not define the walls, so they will have the boundary condition no slip. These are the default values. As far as I know, in a further version, it's possible to define the not defined walls, but in this case, it'll be no slip. But since we are just trying to simulate two phases, and so no slip will be okay, and I hope that it'll run. Now we go to the solver, and we must edit some properties. So the first thing that we must change is a transient write interval, because yes, 0.1, we have to increase the write interval. We will change this to 0.005 in order to have more intervals. And we will change the time step control. The end time will be around 3 seconds. So yes, time step control is it's possible to edit this, but this has no effect. The time step itself, it's controlled by the solver. Um, you can go to the files. You can edit the files and then exchange the control of the time step. I've tried this several times, but I would not recommend it, because if the time step control is internally, then it's better, because if necessary, the time step is increased or it decreased, and this is much better than a fixed time step. So now the parameters for the CFD solver are defined. We can make a double click, and now we write the case. Yes, and this time, in this case, it took a bit longer to write. It took 40 seconds to write. Don't know why it took so long. We can now start the simulation. The simulation will last about 5 minutes up to 7 minutes. So See you in that time. So after 15 minutes and nearly 3,000 iteration, the simulation has finished. We will take a look on the results and we will start Paraview. So what we do is we take a look on the distribution between water and air. This parameter is called alpha, and you see this parameter because we had a simulation with two phases. We go to the last time step. Okay, go again to the first time step and then let um, let it run. Okay, this looks quite interesting. Um, okay, you see the simulation ran 3 seconds, and yes, so it's nearly something that jumps down this step and goes down and then goes up. And the simulation itself, it always calculates distribution between water and air. So if we have more water, then this is red, and if we have more air, then it's blue. So in order to change this, we can go to the color map and we can change this. So we take a look and go to the first step. So of course we assume that water is blue, so this is better. And we can change one more thing to make it look, um, uh, to let it look a bit different. So normally you have here the number of table values. The default value is 256. We can reduce this to 2. So um, what we now will not see are the intermediate colors. Um, so we have here a really hard change between blue and red. You must always say that this is some kind of simulation, and normally we have a distribution. Sometimes it's more yes. So all values between 0 and 100%, they are either blue or red. So of course, as you've seen before, there are many values between that. So this is only for optical reason. We start the flow again, and now you can see looks like water, quite interesting. So and it's really looks like dancing and so on. Looks quite nice. And I ran this simulation also with regardance of the turbulence, and if we regard the turbulence, then this simulation is a bit quieter than so we don't have the effects that it's running through the whole bottleneck. So there are many possibilities to change, but this looks really nice, and it's quite an interesting result. And so, as I hope that you seen how to do a two phases simulation. Now the time step is through that after 3 seconds we have nearly more or less achieved something like an equilibrium. This looks very good. So now our 8th tutorial has finished. I hope that you've enjoyed it, and I hope to see you in the next tutorial. Bye bye.